next would be to establish, or to advertise the prefix, right? So to advertise the prefix, what normally we do is we advertise using the network command, right? So we go and run something called as a network command to advertise the prefix. Okay, so one thing to be noted over here is, if I need to advertise a prefix into the BGP process, so I go to R1. Okay, so let's say I go to R1 and I want to advertise this to prefix. So I need to ensure that how my prefixes are listed in the local routing table. So I go to R1, I say router BGP, my AS number is 100, and I say with a command called as network. I can do either redistribution or I can do a network command. Okay, so when I use a network command, it means I'm going to advertise a prefix, right? So network command, and then I run the prefix that I want to advertise and make sure that the prefix should be accordance to my routing table. So in my routing table, if I look at R1, and if I just go to R1, and if I see here show IP route connected, so I can see that my network 1110 is it's a /24 prefix, and likewise 11.0 is a /8 prefix. So I should update it accordingly in my network statement, right? So I should go to my network statement over here, and then I can define the prefix as 1.1.1.0 followed by a keyword called as mask, and then define the specific mask which is there in the routing table. So if you don't define that, what will happen is, if you don't define the mask keyword, so what will happen is it will read that as a classful entry, and you don't have, so this will be read as 1.0.0.0, and you don't have this particular prefix in the routing table, so ultimately this will not be advertised, right? So let's do that in the action. So if I go to R1 and if I see that router BGP, my AS is 100, I say network, and I say 1.1.1.0, let's say I do that, but I didn't specify the mask keyword. So now what will happen is, if I see show IP BGP, so I don't have this route into my BGP table, right? Because my BGP is not finding, because this will be converted back to 1.0.0.0, and BGP is not finding this particular prefix, classful prefix, in my routing table. So because of which I should do what? I should go and configure router BGP 100. I give a network command over here. So let's delete that. So I should say no network to that, and say network 1.1.1.0 followed by the mask keyword, and define the specific mask which is there in the routing table. Okay, now if you do show IP BGP, that is the command to observe the BGP table, and you can see that the table version is slowly increasing, and you can see that the network command, it is shown as next stop as 0000, so it is locally originated route, or this is a directly connected route. Okay, and you can see the different attributes over here, like metric, local preference, weight, etc. This is my AS path attribute. Okay, we'll discuss all those attributes down the line, but I over here does not mean IBGP. Okay, so we'll discuss that again in the upcoming lectures. But you can see that this prefix is directly connected for R1, and within your own local AS you don't tag the AS number. Okay, so I think you know that, and this is also important to understand. So likewise, if I want to advertise 11.0.0.0, and since in my routing table this is already known as a classful entry, so no need to define the mask keyword, right? So what I can do is I can directly go to my router's routing table, in the global config mode. I can say router BGP, my AS is 100. I can define network, and since it is classful, so I can just define 11.0.0.0. And if I want to give mask, I can give mask 255.0.0.0, but since it's already a classful subnet or a classful network, no need to define the classful mask. Okay, because BGP will go ahead and read that this is classful. This entry will be found in the routing table. Now if I see show IP BGP, I will have this entry in my BGP table as /8, since it is major network, so /8 is not written, and both are my connected routes. So next hop is all zeros, and within my local AS I don't tag my local AS number. Right now, since both this network are known via R1 as a reachable route or as a best route, so you can see that this is valid and this legend is called as best. So since both are listed as valid and best, so that means I can go and advertise to my neighboring router. So if I go to R2, since R2 is my eBGP neighbor, so I can go ahead and see show IP BGP over here, and over here I can see that I have received this particular BGP prefix. I can see my next hop. My next hop is basically my neighbor IP address with which I have formed the eBGP neighborship, and I can see the AS path is prepended. The AS path is prepended, and here the legend I is called as IGP, and we'll discuss that down the line. Okay, so AS path is known to R2 as 100. So this router R2 says that, okay, I learned about 1 and 11 network via eBGP. To reach that, I have to jump one AS hop, and the AS number is 100. That's my next hop. And since R2 says that, okay, the next hop is basically reachable, that is the reason it is considered as best, because for R2, R2 can reach 192.112.1 via its connected route. So if I see show IP route connected, so R2 knows that he can reach 192.112.series network, and it is represented as a connected route. So since the next hop IP is reachable, so this route will enter into the BGP as a BGP route into the routing table. So if I see show IP route BGP, okay, and I can see that this particular routes have entered into my routing table as a BGP specific route with an eBGP AD value of 20, the neighbor as the next hop IP. Perfect. So likewise, what you can do is you can go and form a neighbor relationship between R1 to R3 and R2 to R3. Let's do that. So let's go to R1 and form a neighbor relationship. Router BGP, my AS is basically 100. Neighbor, sorry for that, neighbor will be 192.1.13.3. that's my neighbor, and the remote AS over here is 300. The same story, the TCP/IP three-way handshake process will begin. Let's go to R2. So over R2 I will run router BGP. My AS is 245. My neighbor is 192.1.23.3. remote AS is 300. Okay, and then I have to go to R3, run the BGP with R1 and R2 respectively. So router BGP, my local AS is 300 and my neighbor IP is 192.1.13.1. Remote AS will be 100, and likewise the neighbor for R2 will be 192.1.23.2, and my remote AS will be 245. Okay, so you can see the BGP log messages in the console that the neighbor towards R1 is up, and likewise the neighbor towards R2 is up. And if I see here on R3 show IP BGP summary, I can see that both the neighbors are listed as established between R1 and R2 for R3 point of view, and you can see prefix received as 2 over here, right? So R3 has learned both the prefix of 1.1.1.0/24 and 11 series prefix, both from R1 as well as from R2, right? So if you look into now the BGP table, okay, so look into that. So now R3 says that, hey, I've learned 1.series prefix from R2 as well as from R1. Okay, but if I reach via R2, I can see the AS path is 2 AS hops away as expected, and if I reach it via R1, it is 1 AS hops away, which is AS 100. Likewise, similarly, if I want to reach 11.series prefix, I know it via R2 as well as via R1, but if I reach via R2, it is 2 AS hops away, AS 245 and AS 100 as explained to you earlier, and if I reach it via R1, it is 1 AS hop away. And let us say it is considering as of now the shortest AS path as the attribute criteria to decide the best path, and because of which the path to reach those prefixes via R1 is considered as best, and this best route will go inside the BGP routing table. So if I see show IP route BGP, so the from R3's point of view, if he wants to reach 1 or 11 network, it's via eBGP, AD value is 20, and you can see the next hop is R1 IP address. All right, so likewise if we go to R2 will not have any change, because show IP BGP, if I do, it knows both the prefix now via R3 as well, right? But it will consider the R1 as the best because of the shorter AS path as hops, right? And R1, those routes are locally originated, so that's not a problem. So show IP BGP over here, those routes are considered as locally originated routes. Now last thing in this particular video is, let's say we will go and advertise the R3's prefix into the BGP process and see the propagation. So over R3 I will go and say router BGP, my AS is 300, I'll say network, which is 3330. Since it is classless, I'll define the exact mask as per the routing table, which is slash 24, and network is 33, which is class full. And then I'll see show IP BGP, my own BGP table. I should find that 3 and 33 are listed as my locally originated routes. All right, now since it is reachable to me, since I consider these routes is best for me, then I can go and advertise to my peers, my neighbors, which is R2 and R1. So if I go to R2, I will learn those routes, show IP BGP, and you can see that it has learned the prefix 3 series, via R1 as well as directly via R3, but it will consider R3 as the best because of the lowest AS hops. BGP is kind of a slow protocol, so give it time for the 33 to appear. Yes, 33 is also appearing now, and similarly R2 has learned 33 also via R1 and also via R3, so it is considering R3 as the best because of the lowest AS hops. Likewise, R1 will also learn this 3 and 33 via 2 eBGP neighbors. So show IP BGP over here, it knows 3 and 33 via R2 as well as R3. It will consider R3 as the best because of lowest AS hops, and because of which this best route will go inside the routing table. So if I see show IP route BGP, so this route is going inside the routing table as a BGP route. From R1, it is considering R3 as the best path. Right, so now very simple. Likewise, last thing is on R2, if I see show IP route BGP, it will know the 3 and 33 prefix, which is via R3 as the best path. Now let's do a reachability test between all the 3 loopbacks. So let's go to R1. Can I ping R2's loopback, which is 2222, which is source of 1111. Now since both the routes are reachable or known via both the routers, so they should be able to communicate. Okay, let's see, can I reach ping to 3.3.3.3 with source of 1111? That is fine. Can I ping to 33.33.33.33 with source of, let us say, 11 as an example? They're also fine. There's some issue with R1 and R2. Let's try to understand that. Ping 22 with source of 11. Okay, maybe we'll sort it out. That's not a big deal. Let's see what is the issue. First of all, can I communicate to 192.1.12.2? Things is fine. Show IP interface brief, which is 1 and 11 is fine over here. Show IP interface brief, 2 and 22 is also fine over here. Show IP route BGP. Do I know 1 and 11? I know 1 and 11 via 12.1. Do I know in R1? Do I know? Oh, so R1 is not knowing 2 and 22. Okay, because might be I have not advertised 2 and 22 over here, right? So let's go and advertise that. Router BGP, my AS number is 245. Let's go and advertise 2.2.2.0. Mask is 255, 255, 255.0, and likewise 22. Or you can just give the default one. Okay, show IP BGP should have 2 and 22 now, which is locally connected for R2, and as expected R1 should learn that in the BGP process, in the BGP table. So 2 and 22 will be learned, so it knows about 2 from R3 also, for R2 also, but it will consider R2 as the best because of lowest AS hops. Let's wait for the net for 22. it knows about 22 via R2 as the best. And now if I see show IP route BGP, it knows 2 and 22. Now things should be fine. If I want to ping 2222 with source of my local first loop back, or if I want to ping 22 with source of my loop back 1, things are all fine. Okay, so yeah, I hope this particular part is clear. So in the upcoming video we will run BGP across the other AS numbers, and we'll advertise this respective internal networks of the local routers, and we'll see how it is done. Okay, so kindly practice, keep your practice synchronous with the explanation, so you can do it more. And if there is any queries, let us know. We'll be able to assist you. Thank you so much. I'll see you in the next lecture.